So the goal of the talk or today's session, I'm going to walk through the issue identification, a review of instrumental variable technology, talk about what the conditions are for good instruments, a little bit about the methodology. This is not a fancy econometric session. It's more intuitive, I hope. We'll talk about that. And then some trade-offs to think through when you think about the use of instrumental variables. I'll walk through some examples from the literature. I think the one I'm going to highlight is this big ongoing debate about firm performance and things like ownership or family-run companies. We'll talk about that debate. And then I've got comments from my perspective as more of a consumer or a referee of papers and what I look for when I read papers and think about instrumental variable techniques. And then as time allows, I'm hoping we can have more of a discussion. So to kind of fix your ideas and think about a problem, just to give you some framework to think about as we go through the discussion. Think about the problem of trying to figure out whether firms that are run by family members are better or worse than other firms. Okay, this has been an open question in the literature. People have talked about maybe family-run companies are better, maybe they're worse. On the one hand, they could be better because family member CEOs, if they're in charge, they care about the long term. They care about their family's name in addition to firm performance. They have this commitment to the firm. Maybe that increases investment by other stakeholders in the company and those kinds of things. So that would be plausible. On the other hand, you can imagine that when push comes to shove, they might make decisions that benefits their family instead of the shareholders. That could be bad. In addition, if you think about trying to draw from the labor pool of potential CEOs, a family, at least my family, is a small pool. So that's a tougher thing to draw a good CEO from that distribution. So that might also lead to worse performance. So that's sort of the idea to think about, that kind of a question. Now, if you wanted to test this, if you go back to your first semester or year in grad school and you wanted to test the question whether family-run companies are better or worse than others, what you would probably do is go out and collect a sample. It would probably be a panel because it's corporate data. You'd have some sort of panel-type data set of companies over time. You would need a performance measure. The big example in the literature, as you all know, probably is Tobin's Q, so market-to-book ratio of some sort. You would put that on the left-hand side and you would regress that on some indicator for whether that company, whether their CEO was a family CEO or not, right? And you would be looking at this beta coefficient, asking the question, if it's positive, it looks like family firms do better. If it's negative, it looks like family firms don't do as well, okay? So that would kind of be the basic setup, right? And this is one such regression. And we're going to do this paper, I'll talk about this paper in more detail later, but this is from such a study. And the left-hand side, it's not on the slide, the left-hand side is Q. And if you can't read from the back, they've got negative signs and stars, okay? So this is that kind of a pooled regression. Family CEO is the top row, and that's an indicator variable for whether the family is run by, the CEO of the company is from within the family. You see negative significant coefficients with and without year controls and other controls for size, age of the firm, operating performance, that kind of thing. So if you took this at face value, that would suggest that family CEOs hurt firm value rather than help, right? All else equal, putting in a family CEO diminishes the market-to-book ratio, hurts firm performance compared to other firms, right? So then, if you kind of take the next step and ask the question, well, what's wrong with that approach? What are the issues, right? What else could be driving this? And that, of course, opens up the whole can of worms of endogeneity, right? So the issue is that variable that we are curious about, the family firm CEO dummy variable, indicator variable, is endogenous. And what do we mean by that? Well, the issue here is ordinary least squares regressions, which are still by far our bread and butter as corporate empiricists. Those regressions can suffer from this problem. And those are the regressions still used today in things like capital structure, investment cash flows, corporate governance, and all kinds of settings throughout the literature. Many of us, when we think about writing empirical papers, first thing we think about is what kind of regression do I envision running, right? But then the problem of endogeneity comes up, and it's almost always present in corporate finance. At least I almost feel guilty when I write referee reports saying, of course there's an endogeneity problem, because it's almost so trite that it's almost always there. And as econometricians, what do we mean by endogeneity? And there's kind of a little bit different spin on it. From an econometric standpoint, all that really means is that the right-hand side variables, or at least one of the right-hand side variables, is correlated with the error term. Okay? And if you think about what OLS does, it finds the slope of the regression by taking the errors to be orthogonal to the x's, right? And then that sets the slope. And so if that's violated, then OLS is wrong because it's trying to orthogonalize errors to x's. But if they're in fact correlated, then you're going to screw up your slope estimates, right? So econometrically, an endogeneity problem is just that. Okay? Now, where can that come from? It's from different sources, and we'll talk about this in a little bit more detail. But it can come from measurement error. That my family firm context is probably not measurement error. There might be a little bit, but it's probably not too severe. I probably know who are family firm CEOs and who are not, right? If I was measuring that with noise on the right-hand side, then that could cause some problems. Simultaneity is another one, and often I think, depending on who you talk to, some people, when they say this is an endogenous variable, they really mean simultaneity. That is the kind of variable that is being co-determined by a decision maker. They're simultaneously deciding this and this. That makes sense? You know what I mean? But that is kind of one part of the endogeneity problem. That's more of a structural modeling problem. From the econometric standpoint, the issue of endogeneity is broader than that. The other big one in corporate finance is omitted variables. And we'll talk about that in this context in a minute. But that's another sort of classic problem where something like firm quality or firm growth prospects or managerial ability, those are common things that are likely to drive things in our regressions that we can't really observe. Okay, we'll come back to that. The problem with all this, whatever the source is, it leads to inconsistent estimates. So again, just to remind you what that means even with all the data in the world, I cannot be comfortable that my estimates are going to shrink down to the right beta. Okay, that even with a ton of data, my beta estimate I no longer trust is going to converge to the true number. Okay? Then the related problem of this is one of inference. If I want to infer, is it really the case that family-run firms do worse because they're family-run? That's hard, right? To actually say something causal, that if you appoint a family member as CEO, the firm will likely suffer, that's hard to make that inference. It could just be some correlation. Okay? Something else is saying, typically firms that are poorly run are poor performers also have family CEOs, but it's not because they have family CEOs. To make that last statement, that it's because they have family CEOs, requires us to think more about the specifications. And so if we think about some examples of this in corporate finance settings, just to put a little more structure on it, think about measurement error, right? Things like corporate tax rates or investment opportunities, right? So it's often the case that we want to measure something like what's the company's tax rate to explain capital structure. But we can't really observe the tax rate of the company, and so we have some sort of estimate of that variable we put on the right-hand side. Now here, just to sort of remind you, if the errors on the left-hand side of the regression, we're generally okay. It's just going to add noise. It's going to be harder to estimate the regression because we've got an additional error term in a sense on the left-hand side, but we're okay. If it's on the right-hand side, then the general problem we've got is an attenuation bias. It's going to make it harder for us to find the true effect. The betas are going to be shrunk towards zero. The slopes are going to be shrunk towards zero under typical conditions. By typical, what I mean is that the errors are uncorrelated with the true variable. The true tax rate is uncorrelated with the error in my measurement of the tax rate and with the other x's. It's less problematic for other variables or if the error is an independent variable. So what I mean by that is that if the errors are truly orthogonal to the other x's in the regression, it's not going to contaminate. Okay, you're going to screw up your one coefficient you care about, but it's not the case it's going to be traced through to all the other coefficients. Okay, so it affects this one, but not the others. If the measurement errors are correlated with the other x's, then all bets are off, and it could screw everything up too. Okay, simultaneity is another issue we talked about. An example there would be compensation and leverage. So if you want to ask the question, do managers who have more stock options, and I shouldn't pick on anybody, but if you did this work, I really liked it. So, but if you want to ask the question, managers who get more stock options, they choose different leverage ratios, right? The problem there is that the board, in some sense, is setting both terms, right? They're choosing compensation based on some factors they face. And they're also, through various channels, helping set leverage ratios. So these things are simultaneously determined. Okay, that's an example of that kind of a problem. And as I mentioned before, if you step outside of econometrics for a second and just ask what's an endogenous variable, that's often what people have in the back of their minds. Okay? Then omitted variables come up almost all the time. And we think, an example would be managerial ability. And there, often the argument, the debate in the room comes down to controls. Do I really believe your controls or not? Okay? So if you go back to my example of family firms, what would be a plausible story for what's going on with family firms? A plausible story would be something about the family CEO could be related to their investment opportunity set or the future prospects. It could be the case, for example, that firms that have family-run CEOs have better or worse future prospects. Okay, and they're chosen because of that in some sense, right? Now, what would you say? Well, if I want to run this test as an econometrician, what I need then is a control variable to soak up the investment opportunity set the firm faces, right? And if I could do that, if you think about the ideal data set, what would the ideal data set look like? I would have a perfect measure of the investment opportunity set the firm faces. Then my Q on the left-hand side would be the market-to-book effect beyond the investment opportunity set. Does that make sense? Okay. This also brings up a distinction that is somewhat semantics, but you'll hear people make mistakes in conversation on occasion, of a proxy versus an instrument, right? If I am interested in measuring, if I'm worried about the investment opportunity set containing my regression, then I might look for a proxy variable to throw in the regression. That proxy variable, what that needs to do is it needs to soak up the investment opportunity set to the extent that the remaining x's are no longer correlated with my error terms. Right? That's a definition of a proxy. But throwing in R and D on the right-hand side is not the same as instrumenting for the investment opportunity set. That's a proxy versus an instrument. Okay, I'll come back to that distinction a little bit later. But again, back to my family firm regression. Perfect world, I would put in the right control for the emitted variable that's the investment opportunity set, and then you would believe me that the left-hand side, the Q, Tobin's Q, is now truly measuring market to book, holding constant the investment opportunity set, right? Of course, in practice, you're going to say, well, you don't really have a good control for the investment opportunity set. I still don't believe you've captured the emitted variable, and then we would argue about that kind of back and forth. Okay, so all this brings up different strategies then for how to identify. I want to figure out various ways to identify the effect I'm after. I want to isolate my one thing, for example, isolate the effect of family-run CEOs on performance. And there are a variety of things you can imagine doing to get identification. Okay, so one might be an experiment, right? You would have an experiment where you conducted something where you controlled the variation, right? You were the one who sat down and figured out. You would have a randomized strategy where some people had effects, other ones didn't, right? This almost never happens in corporate finance settings. If we could only play God for a little bit, we could do it, right? But it's really hard for us to sit there and say, I'm going to now take this firm and I'm going to decide that I'm going to flip a coin, they get a family CEO, flip a coin, this firm doesn't, right? That's just doesn't happen in our setting. The next thing you can imagine doing is looking for natural experiments, and you've probably also heard this kind of buzz phrase that's become increasingly popular as we talk about it over time. And those natural experiments is where you understand where the variation is coming from. A classic example would be something like a government reform or a change in tax legislation, right? Some sort of thing where the world was going along, and then there was something exogenous that happened, something that happened because of the government woke up that day and decided to change something, and then we can look and see how firms respond, right? And typically that is a difference in difference approach. So I would take my firm and ask how it changed around that shock compared to the average change of other firms. And I would take the difference between my firm minus the difference of the other firm. That would be the difference in difference. Okay? And that would be another way to try to handle the identification problem. What we're going to talk about more today is instrumental variables. There you have a variable that you trust can provide variation in the data that's not contaminated. Okay, it's going to provide variation in the data that you're comfortable is clean from other confounding effects. Okay? And and then the last one would be something econometric. So you're willing to write down some sort of structure on the data that you're comfortable will then allow for identification. And one example will be fixed effects. Right? We'll come back to this in a little bit. But if you tell me that I have an emitted variable that differs across firms but is constant through time, then if you put in firm fixed effects, it gets rid of the problem. Right? So that would be a structural econometric approach to identifying the problem, because I'm going to sweep out this emitted variable by including fixed effects. Okay? Structural estimation would be another example. So if you're going to, you're taking a model more seriously, trying to estimate a fully specified model that may have various equations or nonlinearities going on that allows for identification because you take the model more literally. Okay, so going back to ID then, go back to the classic OLS regression. So in our context, the Y variable here was Tobin's Q. The variable I care about is going to be XK. I'm going to follow the basic notation out of Woolridge, for example, if you've seen that book. And my XK here then is the variable I care about. That's a family firm CEO indicator. Right? That's the variable I care about the slope the beta sub k on that variable. The problem is I'm worried here is that my xk might be correlated with my area term for one of these reasons: measurement error, simultaneity, omitted variables. Right? There's some reason why I'm worried about. In the family firm context, which one do you think you're more worried about? Measurement error? Probably not, right? I probably know that pretty well. Simultaneity, well, kind of depends on how you think about it, maybe. The one I think is probably the classic example there is omitted variables. That I don't see something like my investment opportunities, and that's driving both the Q and the family firm CEO indicator. So kind of if you want to think about that in the back of your mind, what I'm worried about, that's the case here. And as I mentioned before, if this is true, if the XKs are not orthogonal, then my OLS estimates of the slopes is inconsistent. Furthermore, just to remind you, it's not the case that I can trust all the remainder of my betas as well. Right? In general, I've got the problem that that's going to contaminate the entire slope vector, and they're all screwed up. Okay? So to do this, we're going to try to come up with an instrumental variable, an IV estimator, and we have two key conditions, and I'll come back to these in just a second with more detail. The first condition is that the covariance between my instrument, so think about this as the magic variable that I'm going to use to figure out who's a family-run CEO and who's not. I need that variable to be unrelated to the true error term. Okay? So unlike a proxy, again, just to remind you, if my worry is I have an omitted variable that's investment opportunities, a proxy variable, the whole point of the proxy is that it's correlated with the investment opportunity set. Okay, here the point that I am after is a variable that is correlated with family-run CEOs, but not with the investment opportunity set. Okay, so it's just kind of almost exactly the opposite. I'm looking for an instrument that is uncorrelated with the error term, remaining the regression. And then the second thing is if I think about running a regression, where my family-run CEO is on the left-hand side, on all the remaining X's, so everything, all the other controls in the firm, the left-hand side would be the dummy family CEO or not family CEO, and I include the instrument, I need that coefficient to be significant. Okay? So I need the coefficient on the instrument to help to be significant, and all I'm saying there in words is that the instrument has to partly explain the variable that I'm worried about. Okay, so more on the conditions. And these two conditions answer the question, is this a good instrument or not? Right? So whether you're writing papers or reading papers and you start to see an instrumental variable approach, the first question is, do I believe the instrument or not? And belief about the instrument comes down to two conditions. The first condition is this orthogonality between the instrument and the errors. And that applies, as I said, that the instrument is uncorrelated with the true error. For example, the omitted variable in my regression. Put another way, the only way my instrument can affect the y variable, q, in my simple regression, the only way the instrument can affect q is through the variable of interest. Okay? So in my context, if it's a good instrument, the only reason it affects firm performance is through the family CEO channel, no other channels. Okay? Same kind of statement. The second condition is, as I said before, I run this regression of the variable of interest on everything else in the regression plus my instrument, and then it has to show up. It has to matter. The instrument has to be correlated with the xk, and formally it has to be partially correlated once I've partialed out all the other variables in the regression. Okay? And of note, remember or realize that the second condition I can test, but the first you can't. Okay? The whole problem with the model is I don't know the true errors. So if I don't know the true errors, I can't test whether they're orthogonal to anything or not. Okay? But the second one I can. Right? So really, almost all the debate about good instruments or not comes down to the first condition, whether you buy the first condition or not. Okay? The second one you can demonstrate. So given that, let's say I found an instrument. I'll come back to the example of family firms in a little bit. But let's say I found an instrument, and I'm going to run my model. The way these are almost always done is two-stage least squares. And to run two-stage least squares, you start out with a regression, that regression I showed you before. The right-hand side is your variable you're concerned about, my family-run CEO indicator. And then on the left-hand side, the right-hand side is everything else in the regression plus my instrument. Then I take the fitted values from that regression, call that xk with a little hat, because it's the estimated values, the predicted values. And then I run OLS again, but I plug those in place of the true ones. Okay, so in place of actual family CEOs, I've got a predicted value of whether or not a firm would have a family CEO. based on the first regression. Okay? Plug that in. It's advisable to either be very good with the software or to use a package. Mistakes that can be made if you don't is to forget to include the other x's in the first stage, right? So even though the instrument is the z, you have to include all the other estimates. You want only the partial effect of the instrument on the variable you care about. The other problem is standard errors. If you think about it for a little bit, you realize that this variable is estimated with error, and so you're throwing it into a second stage regression. That's going to compound or affect the standard errors of this OLS regression. So if you do it manually, you have to be careful with the standard errors. Is the point. Okay. It's also worth noting that an IV estimator is consistent but is not unbiased. Okay. So if I have all the data in the world, I'm going to get down. The distribution is going to converge to the right number. But for any small amount of data, I cannot say that the expected value of the estimator is the truth. Okay, so I still have some bias problem. Where is that a bigger issue? That is a bigger issue when the sample is small relative to the number of instruments. Put another way, the bias is less of a problem when you have a lot of data, which makes sense, compared to how many instruments you've got. Okay? This is especially problematic if the instruments are weak. So if we think about, you might find something that barely explains the variable you care about. You think about it has a correlation of 0.01 or something, but it's really there. That's a weak instrument. It's going to be hard. Your bias will be worse. It'll be harder to pick up the truth. Okay, so that's, again, trying to review the methodology. Now, things to think about in terms of the trade-off. What are we doing when we use instrumental variables? The trade-off, or thing to think about, is what is the source of variation we're using in the data to estimate our effect. Okay? If I run traditional pooled OLS, I am using all of the variation in the data to estimate what I care about. Okay? So another way to say it, if I think about my family firm example, if I run pooled OLS, I'm going to be getting variation from firms changing over time. Some firms will, their Q will change or their family CEO will change. I'm also going to get variation across firms. Some firms have higher Qs than others, right? Some firms have family-run CEOs, some firms do not. All of that variation is what I'm going to use, okay? And I'll come back to the sort of pros and cons of that, but if you think about it, that's more powerful, right? I've got more variation, so it's going to be easier for me to pick up an effect if it's truly there. That's the good side, okay? If I go to fixed effects, I'm only isolating the time series variation. I'm only picking up variation, for example, within a firm over time. Okay? So I'm only going to be, in my family-run CEO example, I'm no longer going to worry about why some firms have high Qs and some firms have low Qs. All I care about is why within a given firm did their Q change over time, and is that related to when they appointed a family CEO? Okay, makes sense? Okay, so that would be the within effects estimator, the fixed effects estimator. I'm isolating time series variation. With an IV regression, then I'm getting often an even smaller slice of the variation. I'm only getting part of the variation I'm comfortable with, that part of the variation is truly exogenous. Okay? So I'm taking this full amount of variation, whether it's in the cross-section or the time series, and I'm going to say, well, this slice of it I believe is truly exogenous. And I'm going to use that slice of variation to try to see what the effect is in the data. Okay? So the point of that then is you have to realize that what you're doing is you're throwing away a lot of variation. Okay? You're sacrificing a lot of variation for getting less variation, but that you believe is really clean. Okay? So that choice then leads to the costs and benefits of the approach. When you run traditional pooled OLS, you're using all the variation. It's transparent. It's easier to generalize. When you're using all the variation, there's not arguments about what happens in this part of the data. Right? You can figure that part out. Then you have more power. Right? The cost of this is all this endogeneity concerns. I worry about init variables and all the other stuff. Fixed effects, I'm only using the time series again. I've got less power, right? I'm throwing away why some firms have high Q and some firms have low Q. So I have less power, and I can't say anything about the cross section. I can't explain differences across firms, right? But now the pro of that is I've controlled for firm-specific emitted variables. Okay? IV regressions, I've isolated this exogenous source of variation. I've got less power, right, because I'm only using the slice of the variation in the data. It's harder to generalize. right? It's harder to say, is what is true for this slice of the variation true for all the variation or not? Okay, that's a harder statement to make, right? You're trying to extrapolate from this part to the entire data set, which is harder. But the return on that is that you have the cleanest fix. If you believe the instrument, the cleanest fix for endogeneity. Okay? So that brings up really the common tension to think through when you think about instrumental variables. The common tension here is, on the one hand, the nice part about them is the clean variation. I can isolate the part I'm comfortable with. And the nice part about that is I've got variation that is outside of the control of who's making decisions. So I've got reasons why I leverage changes that are not driven by the CEO or the board making that decision, okay, for example. Versus the lower power and the relevance of the local effect. And the idea approach is not very informative, in other words, about non-results. Right? If you read a paper or write a paper or think about a paper where you end up, the punchline of the paper is you don't find anything. Right? That kind of a punchline with an IV estimator is not very useful because it's a low power estimator. So with a low power estimator, I'm less comfortable that I can conclude anything from the fact that you didn't find something. Make sense? Okay? So that's one point. The IV approach is utilizing agents that change their behavior because of your instrument, but not necessarily everybody. Okay? This has been framed as a heterogeneous response problem. Another way to say it is, let's say there's some little shock you've identified that's very clever that's an instrument. Some people respond to that shock, some people do not. But the IV estimator can't say anything about the rest of the population that would not have changed because of the shock. Okay? An example, this is a famous example from the econ literature that many of you probably know or have heard about. This is goes back to this big question of are wages affected by schooling? Right? So you'd like to run a regression where the left-hand side is wages, the right-hand side is how long you went to school. Right? The problem with that is all kinds of limited variables. If you're, professor's kids, then you probably, had pressure to go to school. Maybe your parents were smart, right? So all those things affect both schooling and wages, right? The ability of the students, for example. Okay? That's an endogeneity problem, limited variable problem, for example. And so it makes it hard to disentangle. And the clever fix by Angus and Kruger was that they looked at what quarter of the year you were born. Okay? And the idea being that if the school cutoff is January 1st where you live, then if you're born January 1st as of a certain year, you'll start school earlier, for example, or later, depending on how you think about it. But the law says you have to go to school till you're 16. So depending on when you were born versus when school starts, then what quarter you were born in will affect how long you can stay in school until you want to drop out. Okay, does it kind of make sense? Right? So what they did that was clever was then they used the quarter you were born in, which you can think is plausibly exogenous. We had this conversation at dinner last night. Somebody was telling me that apparently this is under debate now, that maybe high-income people have children certain quarters of the year. Okay? There are different effects there, which I won't go into on film. But it's interesting to think about. But forgive me, take it for a minute that that's exogenous, right? That what quarter you're born in is just given randomly. Okay? Well, again, the cleverness of this estimator is using people who might drop out when they're 16 or 17 years old and comparing that to when they were born. Okay? That result is very tough to extrapolate to professors' kids. Okay? Because even if they find an effect that schooling drives wages, they're using the variation around people who might otherwise drop out. Okay? It's hard to say whether more schooling really impacts wages for people who go get PhDs. Does that make sense? Okay? So the point I'm trying to make here is about the generalizability of IV estimators. Right? This paper is extremely clever and clear about how they isolate the variation using quarter of birth, but their punchline, and everybody knows this, but the punchline is based on people that are about 16 or 17 who might drop out. And it's up to the reader to think, am I comfortable asking or thinking about whether that really explains all the variation in schooling and income. Okay? All right, so on to some more examples. One of the most well-known examples of this sort of ongoing debate is the literature on whether ownership affects firm value. Okay? And there's this intuitive trade-off we all have in mind about ownership and value. On the one hand, the more the management team owns of the firm, the incentives are better aligned. On the other hand, the more they own, the more they're entrenched, right? So you get this nice kind of tension between incentive alignment versus entrenchment. Okay? And so that's kind of what we're after. The problem is there are lots of things that drive ownership and value both, right? Lots of reasons why there's variation in those sort of variables, and can we really control for those things? And so, a lot of this literature starts from Hartzell and Vishny, and here's the picture from their paper. And they run a regression, Tobin's Q on the left-hand side, board ownership on the right-hand side, and they get this fairly well-known piecewise linear relationship where ownership is good for Q up to a point, then it looks bad, and then it is good again, but at a lower slope. Okay? And the interpretation that is commonly attributed to this is, in this range, you're improving incentive alignment, right? Over this range, people are becoming more entrenched. That's worse. In this range, entrenchment's a little bit fixed, and incentives are getting better. Something like that. Okay? So that's their regression. So what are they doing? What variation are they using? They're using one cross-section. Okay? Their cross-section of data is 371 Fortune 500 companies in 1980. Okay? But they're going to use the entire cross-section, all the cross-sectional variation in the data. Okay? Well, the trade-offs, it's an important, intuitive, and very highly cited result, right? We all probably know that paper, have heard about it, and read it to varying degrees. I looked before I was doing the talk, 780 sites on Social Sciences Citation Index, and it's timeless in some sense, 70 so far this year, right? So it's a huge, important paper with an important result. Because of on the other hand, because of their strategy by using one cross-section, they have very limited ability to use controls in the data, okay? Their controls in the main regression consist of R&D, advertising, and a 3-digit SIC code dummy. Okay? So you're asking, if you're worried about admitted variables, you're thinking, do I believe that those substantially control for everything else I'm worried about? And so, as a result, there's still lots of endogeneity concerns. And the authors are aware. So if you go back and reread their conclusions, they're very careful and clear about how they think about what they really found. They say that that range, where the Q shoots up early, could be because high Q firms may just grant more options, right? Growth companies may want to grant more options to better align incentives because incentive alignment is more important in growth companies. Okay, that could be driving the initial slope. And the other thing I talk about, for example, is that intangible assets could be driving both Q and ownership. Okay, and they don't really have a control beyond R&D and that sort of thing for the intangible assets of the company. One more example. McConnell and Gervais come on a couple years later, and they find the other familiar picture people talk about, this inverted U shape. Right? Ownership's good up to a point, and then it becomes bad. Okay? And that point of inflection is on the order of 40 to 50%. Okay? So, important intuitive results. Everybody starts a lot of research, spurs a lot of research. Then, another example in that literature is Himmelberg, Hubbard, and Palya. Okay? So, Himmelberg, Hubbard, and Palya come along, and they look at it in a panel data context. Okay, so now they've got firms over time rather than just a cross-section, from 82 to 92. And they find that the existing results are not very robust to controls for endogeneity. And more specifically, what they're going to do is really focus on firm fixed effects. So their story is there are lots of reasons why ownership and Q differ across firms that are admitted that we just can't control for. So instead of trying to control for all those things, what we can do is isolate time series variation and ask, within a given firm, if managers own more or less over time, how does their Q change? Okay? And what they find is a non-result with the fixed effects, that the variation over time of ownership is basically uncorrelated with the variation in Q over time within that firm. Okay? And that's the sense in which they mean that the results are not robust to endogeneity concerns. They do present pooled OLS, some stuff with 3-digit SIC code effects, and they have some admittedly weak IV estimates, okay, which they say are promising but not conclusive. All right? Their instrumental variables are firm size and volatility, okay, which they argue might be causing changes in ownership, but not necessarily causes changing Q directly. Okay, and that's the debate about whether you believe the instrument or not, is do you believe those conditions, right? Is there any other reason why firm size and volatility might directly affect value other than through the ownership channel? Okay? But the thrust of their paper is mainly about the fixed effects results. Now the trade-offs on this in this paper, the next step, is they're more careful about endogeneity. They hit it head on and talk about it a lot in the paper, right? And they have results up to the fact that you believe that endogeneity is firm-specific but fixed over time. Okay? If you sort of buy that, then they've handled the endogeneity problem properly. And the results suggest that these endogeneity concerns matter, right? That the firm-specific emitted variables may be important. Now, what's the trade-off again? The trade-off is power versus cleanliness in the data, if you will. And so the con of their approach is they have less power. They're only using time series variation. That's a lot less variation, so they may not pick up anything. Okay? And that was a point made by Zhao in a later JFE paper who says, it could be that the reason they don't get results is that these things don't change much over time. In order for fixed effects to find something, you need a lot of time series variation, right? Because you're throwing away all the cross-sectional variation. So you need changes in time to be big enough to pick up your effect. And if ownership doesn't change that much, then you have no hope. Okay? So maybe it's not endogeneated at all, you just had a low-power test. Make sense? Okay? So, going on from inside ownership, go back to family CEOs. So to talk about it a little more carefully, a similar debate, similar issues, right? Now, just slightly differently, instead of worrying about inside ownership, what we're thinking about is this question of who runs the company or not. Okay? And again, the simplest test, as we went through before, would be to use all the variation. Regress Q from a pooled sample on a family ownership indicator. Okay? Or you can isolate the time series. You can take performance changes around family CEO turnovers. Okay, we mentioned this difference in difference approach again. And this was done by Perez-Gonzalez in an AER paper. He did a difference in difference test around CEO turnovers. What did he do? He took the change in performance of the company, given that there was a new family CEO coming in. That's the difference, one difference. And he compared that to the change in performance when there was a new CEO who was not a family member involved. It'll be on tape. It'll be great. Okay? So, one difference, the other difference. The difference in the two differences is his estimator. Okay? And why is he doing that? He's worried about the fact that performance could change around all CEO turnovers. Right? So it could be the case that any CEO comes in affects performance, on average. Okay? So he's going to take the average performance change for ones who are not from the family, take that away from the performance change from ones that come from within the family. What he finds is that there's underperformance following family CEO successions. And another part that's clever about the paper is he finds this underperformance is stronger from family members who didn't go to good schools. Okay? So the question you might have is, do I really believe the result? Well, one way to firm up the intuition is to ask, is it stronger in places I think it should be stronger? Right? If you believe that family-run CEOs are not the best draws from the labor distribution, then you can ask the question, well, if a family member went to Harvard, right, it's more likely they have good ability. Okay? And so we're going to compare people who went to Harvard-type schools from those who didn't, and you find this difference in the effect. Okay? So that's a difference in difference. Again, not an instrument approach yet. Okay? But why might there still be problems? That sounds pretty good, right? And admittedly clever. So why am I still worried about endogeneity here? Well, think about two sources. In the cross-section, I've got these emitted variables. Okay? For example, family CEOs are better able to remain in place at firms who are doing well, right? If the firm is doing well, then nobody throws a fuss, and the family CEO gets to stay in business. Okay? And it may not be doing well because of the CEO. In the data, what would that look like? It would look like firms with high Q have more family CEOs, right? But it's because they had high Q, the family CEO stayed. Make sense? Okay? That would be a cross-sectional problem. In the time series, okay, let me go back to earlier difference in difference. The difference in difference is better about this one, right? Because it's utilizing the time series changes. But even in the time series, there might be still a emitted variable problem. How might that look? And you can take either side you want. But let's suppose that standing today, we expect there to be good times. And because there's good times, the new CEO is more likely to come from inside the family, for whatever reason. Okay? If that's true, then family CEOs are in fact actually worse than the difference in difference test shows. Okay? Because when they're appointed is endogenous. Okay? That the reason it was a family CEO succession is correlated with future firm prospects. Okay? Alternatively, maybe you don't like that one, take the other side. let's suppose that when bad times are expected, you're going to put a family member in. Okay? If that's true, then the difference results suggest that family-run CEOs are actually better than we thought. Okay? Either way, there's a problem. Okay? So what do we need? We need an instrumental variable, something that is correlated with CEO succession, but not otherwise with firm performance. Okay? And this leads to the next paper, which is Benenson, Nielsen, Perez-Gonzalez, and Wolfenson, okay, where they solved the problem. And back to the first regression in the second or third slide that we were saying, wouldn't it be nice if we had an instrument? They have an instrument. Okay? What they end up doing, which I think is very clever, is they use the gender of the oldest child. Okay? Plausibly exogenous. Right? It's kind of hard to imagine how that would be correlated with eventual firm performance. Right? Directly. Okay? So they've got the gender of the oldest child, and they go to Scandinavian countries that have all this wonderful, albeit slightly creepy data on all measures of families, right? So they have data where they know here's the CEO of a family-run company, and here are his or her children, okay? And they know genders and all that other stuff. So does it meet our two conditions for a good instrument? Is it plausibly exogenous? Well, again, that's the condition we can't test. Right? I cannot directly test whether the only influence of firstborn child's gender on Q is through this channel, but I believe it. Okay? It seems like a goof, right? I need the gender of the oldest child not to otherwise affect firm performance, except through this one channel, and I buy that. Okay? But again, you can't prove it. Okay? The second thing is it correlated with succession? Okay? And I'm not arguing it should be. Right? But just is it? Is it the case that, and what shows up in the data, that family businesses are more likely to be passed on to male heirs? Okay? So if the first gender of the first child is male, then it's more likely it's passed on to that person to run. Okay? That's what they show. Again, that is testable, and the evidence suggests it works. So here's the first stage regression. And again, if you're in the back and can't read it, the left-hand side variable now is an indicator for whether the CEO is a family CEO or not. Okay? And that's our endogenous variable we're worried about, right? Then the right-hand side, the big thing is the gender of the firstborn child is a male, a dummy variable for that effect. And then they've got some other controls. And you see this, big positive coefficient that it's more likely that a family company, the CEO will be from the family if the first child happened to be a male. Okay? And then they've got it different ways, different control sets. That's the first stage. So it meets that condition as well. So, two-stage least squares, take the fitted values from that stage with all the appropriate other variables on the right-hand side, plug it in place of the 0-1 family indicator. So now our key variable is the predicted value from that first stage regression. Okay? And you run it, and these are the two columns I showed you before. Okay, where they were not instrumenting yet, right? And we talked about how they had negative coefficients suggesting that family members showed performance, but maybe you didn't believe it yet. Okay? Now they show, you go down, instrumental variables, this third column, gender of the first child is their instrument. They use other things as well, whether you have a male child at all, how many male children you have, the ratio of males to total children. So they do different things, but it's all playing off this idea that male heirs are more likely to control the company at some point. Okay? And you see negative coefficients and a lot stronger magnitude than before. Right? So you're getting 0.126 instead of 0.01. Right? So on the order of, ballparkish 10 times the impact. Okay? All right, so that's an example. Let me give you just a few of my thoughts, and then we'll open it up for discussion. Okay? So some more observations. These issues about identification and endogeneity are almost impossible to ignore now. If you look at, this is my take on the literature and as well as working papers, if you look at the way that the progression is going, it's more and more towards that area. Okay? More and more papers are worrying about using the phrase how I identify things. They're worrying about endogeneity, being more careful. If you look at job market candidates, at least the ones that we talk to in empirical corporate finance, it looks like a huge chunk of the candidates we interview do one of two things. Either something clever about identification or structural models in corporate finance, which is probably a smaller set, but a few of those as well. Okay, so my sort of take on the way things are moving, this is getting more and more prevalent. We seem to be moving more towards where labor economics has been for quite a while, okay, methodologically. So you've talked to labor economists, we've been slow, but it seems to be moving more that way. Some would argue this is maybe going too far, that people are spending more and more time in a locked room trying to be clever and think of the perfect cute experiment and less time worrying about what really drives most of the variation in the data. Okay, that's a debate, which we can talk about. I'd be interested in your views on how that's going. But I've heard, we've had these conversations in the halls, I hear it at conferences, are we over-rewarding cleverness or not? Okay? I think it's worth time, no matter how you end up writing your papers, I think it's worth time thinking about and writing about what variation you're using. Okay? So, for example, a lot of our theories, or at least, and I mean kind of loose theories in the front end of a paper, a lot of those things are a more natural story either in the cross-section or in the time series. Right? If you write the front end and you say, when firms are hit with this kind of an effect, they change what they do, that's a time series story. So then it makes sense for the second half of the paper to run time series type tests. Right? Alternatively, if your front end is all about different kinds of firms, that's probably a cross-sectional story, so you want to think about looking for a cross-sectional test. I think even if you want to be cute and clever and be very, very careful about a source of variation, I think it's worth spending time to at least show all the variation. Okay? Again, for reasons of power and just, be direct first and then you can be cute next. I think is worthwhile. Okay? And if you look again at the example of Danish family firms, that's what they did. Right? They would first show you pooled OLS, warts and all, right? And then go on to show you the IV estimators. Okay? And there's this trade-off we talked about between power and transparency against cleanliness. Okay? It's often helpful to kind of go through this progression. Pooled OLS, all the variation, fixed effects, time series variation, IV, part of the variation. Okay? More things, mechanics. It's two-stage least squares is by far kind of the industry standard. As I mentioned before, it's probably safest to use a canned package to do that unless you want to write the code yourself. It's not real believable to have a ton of instruments. So good instruments by their very nature are rare, right? So the fact that you have 10 in a regression makes it less believable rather than more. And there's also this bias problem I mentioned before. When the number of instruments is large relative to the data set, then it's harder and harder the bias is more severe. Remember that IVs have low power, as we mentioned, so it's not a great technique if the punchline of your paper is, I don't find anything. Okay? Lastly, I would encourage everybody to think carefully about the two conditions. Show the first stage, which is the one condition you can show. Right? I'm surprised often when I get papers to referee or to read and they have an instrument but they don't show the first stage. Right? Then I'm left really wondering how powerful that instrument is. Is it really there or not? Okay? So show the first stage. It's the one you can. It's the one condition you can show. And discuss the second condition. Discuss that the IV is plausibly exogenous. I often referee papers that come in and they've got a variable that they're using as an instrument, and it's somewhat surprising that they often, maybe one sentence or a throwaway comment that's reasonable. Okay, if you're going to push the IV idea, that's the whole nut, right? The whole issue is, do I believe that you found something that only works through this one channel and not the other way? Okay, so you've got to spend time with the reader and be very clear about why you think that's reasonable. Okay? As a consumer of the research, or when you're thinking through this, go back to these two conditions. That's the question. The question is, do I buy these conditions or not? And I was trying to think of an example of an instrument I could pick on, and I was very afraid of getting somebody in the room. So I picked an accounting paper. Okay? So if you're an accountant, then or you see the tape, there are no names. Okay? We'll protect the guilty. All right. But there is a strand of literature, and people have sort of done this, and I want to open it up to see what you think. But where they've done things like, they say, this variable is endogenous, I understand that, so as an instrument, I will use the industry average of the variable. Okay? And that might be okay in some contexts, but not in others. That's the point. Okay? just to think through what is that really saying about the data, and do I buy that assumption or not? Okay, so the example I pulled, there are a few papers that have done this, where they have used the average amount of stock options granted in an industry as an instrument for how many options that firm grants. Okay? And the idea would be that I understand that this firm is going to grant some number of options, and that's endogenous to that firm. So in place of that firm's options, I'm going to use what the industry would predict should happen. Okay? So the first stage of that kind of test is that you would run some sort of pooled industry-specific regressions over time of firm option grants on the industry average option grants. Okay? So what does this imply? What is necessary for this to be a good instrument? Take the emitted variable problem, okay, for example. What you have to be able to be convinced of for this to be a good instrument is the emitted variable problem varies across firms within an industry, but not substantially across industries. Does that make sense? Okay? So back to emitted variable problem. What I'm worried about, for stock options, take growth opportunities. I'm worried about firms with more growth opportunities use more options and also do something else. Okay? So if you're going to use industry average stock option grants as an instrument, what you have to convince me of is that the emitted variable about growth opportunities does not substantially differ across industries. Okay? Or you have enough controls to do that. Okay? That the only real endogeneity you're worried about is hold an industry constant. It's why firms are scattered around the industry mean. Okay? What you're doing by this technique is you're saying the endogeneity I'm worried about is how firms distribute themselves around industry norms, but not how industry norms differ across industries. Okay? Does that kind of make sense? And that may be true, in which case it's correct. But in a lot of contexts, I don't think it's obvious. Okay? So that's what would have to be true. And then think about, if this is measurement error versus emitted variables. If the problem of endogeneity I'm worried about is measurement error, then using an industry average may be really good, right? Because an industry average, some will be above, some will be below. If I average things, the measurement error will sort of cancel out. So the use of industry averages as an instrument may be a really nice fix when I'm worried about measurement error. But it's hard for me to think in a emitted variable context of a situation where an emitted variable doesn't vary substantially across industries. Right? So I think there's a difference there about why you think you have an endogenous variable and what your specific application is. Okay? And if you think about it, just to convince yourself that this is an issue, if you think about what this approach is doing, if I take just the partial component, the fitted value for my first stage regression, every firm in an industry has the same predicted value. Right? That's the whole point. Okay? So, you can convince yourself if that's true, I can't use industry dummies anymore. Right? Because it's going to soak up everybody's the same thing. Right? So if you want to think about when this is a good instrument or not, if you're comfortable running that regression without industry dummies in it, maybe it's okay. Right? But if there are enough things going on in the data that you don't trust, if you don't trust that industry dummies should be left out, then this approach is going to have issues. Okay? Let's see. So I'm about, I think, almost on time. Right? So let's open it up and hopefully have a discussion. Otherwise, I'll call on people. Right? Questions, comments, anything?
Yeah, it'll
Stone silence.
take a while. So
It was sufficiently unclear that you're lost. No?
email.
Yes, sir.
I just have one question. You mentioned two stages, whereas I've read a paper where the author said...
Right. That, in my memory of that, and I forgot to brush up before I came, but my memory of that is just one more iteration where you use the standard errors from two-stage and then redo things again. It's like a GLS kind of equivalent. You run OLS, that gives you variance covariance matrix, then you reweight the data and run GLS, for example. It's a similar analogy, so is the way I remember it. So two-stage least squares, run the data, then you're going to do it one more time using those estimates to refine the weights that you put on the data. Does that sound right? You might want to correct me. I think that's right. Subject to not being corrected, I think it's right. Okay. What else? Yes, sir.